We're going to look at how we can use some of the knowledge that we've gained about angles and use them to solve problems where we have unknown angles. So for example, we can use the fact that the sum of angles in a triangle is 180 degrees. And we can use the information we've looked at before about corresponding and alternating angles to get solutions to problems. We're going to look at two examples, and here's the first one. This is a triangle problem. It's a triangle with one edge, one line lengthened straight out, so we have a straight line. We have one angle in the triangle given to us, the 75 degrees at the top, and we're told that the exterior angle is 115. We want to find the other angles in that triangle. So first of all, we're going to use the fact that the angles on a straight line is equal to 180 degrees to work out that bottom right hand angle. So 115 is the exterior angle, which means the interior angle must be 180 minus 115, which means it's 65 degrees. So now we know two of the angles in our triangle. We're also going to use the fact that the angles in a triangle we know add up to 180 degrees. So the third angle in the triangle is what's left after we take away 75 and 65, and so that's 40 degrees. So using those two pieces of information, we've been able to work out the other two angles in that triangle. Okay, here's our next problem. This is more complicated. Again, we've got a triangle sat on a straight line. We've also got another line where we're given one angle. So we've got a 40 degree angle, we've got angle D in our triangle is 68 degrees, and angle E is unknown. And we're told that the two lines AB and DE are parallel. If these two lines are parallel, then the angles at C and E are corresponding angles, and so they're equal. So the angle E is 40 degrees. So that's using one of the simple parallel line facts we looked at earlier. Then the sum of the angles in the triangle is 180 degrees, which leaves us with 180 degrees minus 40 degrees minus 68, and that leaves us with 72 degrees for the final angle. So now we know all of the angles in the triangle, which is what we were asked to find out. Okay, I did say we were going to do two problems, but I think you'll agree that these are so much fun that we're going to do a third one. So we're going to find some angles in a quadrilateral. And the fact that you need to use here is the sum of interior angles in a quadrilateral are 360 degrees. So the quadrilateral we're going to look at is a trapezium. And a trapezium is a shape that has two of its sides that are parallel. And in this case, it's the top and the bottom sides. So we're needing to find all of the missing angles. Let's start with the angle at D. So the angles in a complete turn are 360 degrees. So that angle there at D is 360 minus 300, which is 60 degrees. That's quite straightforward. Now we can use our parallel lines to say that the alternate angles GDC and DGH, the ones circled by the red rings, those are alternate angles. So one of those angles is 60 degrees, therefore the other angle is going to be 60 degrees as well. Then we can again use the fact that the angles on a straight line add up to 180 to work out that interior angle there as being 180 minus 60, which gives us 120. And then finally we're going to use the fact that the sum of the angles inside a quadrilateral are 360 degrees to work out that final angle at C, which is therefore going to be 70 degrees. The important thing of any problem of this kind is to make sure you do a number of things very, very carefully. You should always carefully label a well-drawn diagram. Secondly, you should write down any facts that you know that you think are going to be useful, and then just work through the question methodically, bit by bit. Don't try and solve it all at once, and certainly don't try and work out all of the angles without writing anything down. That way you are absolutely certain to make mistakes.